Hello everyone and a warm welcome to you. My name is Shama Banerjee and I am the Senior Editor at Nimbus 90, and it is great to have you with us today. We are in our finals episodes of our In Conversation with Digital Leaders series, where each week we have spoken to a digital leader across different industries about their IT strategies and how they are building their digital advantage. So this series is all about getting a front row glimpse into different IT strategies, and then also giving you all the chance to discuss what you are doing in your organizations and what challenges you're facing with your peers and with Equinix experts as well. So today we are hearing from the Met Office. We have James Tomkins joining us today. He is the Chief Architect at the Met Office. And he has been leading that architecture function for several years, aligning organizational transformation programs and providing governance and assurance across the delivery. So he joined the Met Office in 2012 and previously worked at Oracle and the Landmark Information Group as well. So James, thank you so much for joining us today.
No problem.
I'll now hand over to Lorraine Wilkinson, who is the director. She is part of Equinix's UK leadership team, and she is responsible for implementing and progressing Equinix's sales strategies in the UK. So, Lorraine, thank you so much for being here today. I will hand over to you.
Thank you so much, Shama, and welcome everyone, and thank you for joining us today. I guess one of the great things about working for Equinix is the opportunity to talk to people from a wide variety of industries. And I'm really delighted to be speaking to someone from such an interesting government department as the Met Office. Talking about the weather is one of our nation's pastimes. So James, thank you so much for joining us today.
No problem. Glad to be here.
Thank you. So to get the conversation started, I'd like to begin with our first question. So whilst digital transformation is certainly not new, I think in the past 18 months, we've all been impacted in both our personal and our business lives with unprecedented disruption. So to start this conversation, can you share with us some of the shifts you've experienced within your business over the past, in real terms, actually, I was thinking about over the past 18 months, but I'd actually really like you, James, if you don't mind, talking about the journey that the Met Office has been in over its history and share with us maybe some of the accelerations you've seen in transformation over the past several years.
Cool. Yeah, no, that'd be great. As so for anyone who doesn't know, or hopefully everybody does, the Met Office is the National Weather and Climate Service for the UK. And we've been doing that for just over around about 160 years now. So our first forecast was on the 1st of August 1861. And we've been working ever since then to make them as accurate as we possibly can. So yeah, through that sort of 160-year journey, really, there's been, it's been characterized by many a transformation journey, if you like, and I guess I'll run through some of those in a sec, but what we kind of see is the cycle time shortening, if you like, on the time it takes that transformation to happen. So our first kind of incarnation as an organization really took sort of 100 years to mature, really, from 1861, where forecasts were produced by hand with mathematical calculation, where computers were people rather than machines, the invention of the electronic telegraph made it possible for information to be communicated in a timely enough way that it made weather forecasts viable at a kind of national scale. So through that iteration, really, that lasted for almost 100 years, through to 1965 was the date of the first operational supercomputer at the Met Office, where forecasts were sort of routinely produced by modeling and through supercomputing. So that first transformation journey took, best part of a century. I think probably I'd characterize the next cycle of transformation lasting roughly half that, maybe about 50 years, when we saw the kind of advent of cloud computing. That's when we started to move from a kind of dominant pattern of infrastructure, from custom-built infrastructure like the first supercomputer was, through to slightly more product-based supercomputing and mainframes and that kind of sort of significant infrastructure investment, through to effectively infrastructure as a service and platform as a service starting to sort of become a serious paradigm within the Met Office in the sort of early 2010s, around about 2012, 2014. So that kind of paradigm of building infrastructure, building physical networks, running that infrastructure ourselves, managing all of that as a means to deliver the services that we deliver, because there wasn't an alternative. You had to build it yourself and you had to run it yourself. Those were the sort of dominant design at the time. When we first saw cloud coming in, I think in sort of around about the early 2010s, I guess we kind of thought, we've been running this pattern, this sort of big infrastructure pattern now since the early 1960s kind of thing. That's going to take a long time to sort of phase out. Infrastructure as a service is a great opportunity. We'll take that opportunity in a limited fashion, but we've got plenty of time to think about that transformation. And I think what we've seen over the last kind of 6 or 7 years is really actually the speed at which that's happening has been really interesting. So when we first started our cloud adoption journey, we perhaps sort of did the things that most organizations did, which was pick off, the fairly either new applications that could be delivered on kind of greenfield into public cloud environments, or taking sort of this kind of scalable edge of their business, perhaps the digital applications, and looking at sort of content delivery networks and things like that as a first foray into cloud, and thinking, that's the sort of safe cloud stuff, and it's going to take a long time for hyperscalers and public cloud to make its way back into the core business. But obviously it's only sort of 7 years since 2014. At the start of this year, we signed new agreement with Microsoft to provide supercomputing for the next decade. So I think even 3 or 4 years ago, there were certainly large chunks of the organization who thought the supercomputer was going to be with us in our data centers for many years to come. But really, that some of those assumptions have changed dramatically, really, over the last couple of years, as that sort of transformation to public cloud platforms has really accelerated.
Yeah, I mean, it's a super interesting story, that, James. The 100 years to the 50 years to the 6 or 7. It does beg the question about kind of what we see, the timeframes being for the next transformation. I know you talk about this contract with Microsoft actually being for the next 10 years. But I guess organizationally, the transformation journey you're on now requires much more collaboration within the organization. And have you seen the role of IT change within the organization? And has it somehow become more important as a consequence of what you're now doing?
So in terms of collaboration, the sort of the pace at which that transformation happens is causing collaboration within the organization certainly to be an absolute necessity, because I think over the kind of 50 to 60 years of the kind of dominant infrastructure design that we had of building, running our own infrastructure, the organization builds up a very large number of kind of silos over that period, in terms of areas of accountability and responsibility get entrenched, they get specialized, and people build up those particular kind of silos. And when you need to move much more rapidly and you need to transform, those things become barriers and constraints to you doing that. They're enablers for quite efficient operation when you build those silos around business operations that you're executing all the time. But when you have to change those, then suddenly they become constraints and they become inertia to being able to move quickly. So we're looking at a range of things really to help us migrate or transform from that kind of sort of the siloed environment that had built up around the previous dominant design of how we deliver services, to try and move to how we need to deliver technology and meteorological services in the future. So 2 things we're doing at the moment to try and perhaps reshape ourselves is, one is adopting a capability-based approach to the organization. We'd previously adopted a sort of a process-centric organization, but what we're doing much more now is focusing on our capabilities, and we've recently worked at articulating the whole organization in terms of business capabilities, and we're looking at how we organize ourselves to support those. And almost a refinement or evolution of that thinking, if you like, is thinking about ourselves as a platform and trying to put kind of platform thinking at the center of the organization, and moving away from perhaps those kind of traditional IT silos of, if you're needing to build an application, you're used to having to think about it from the ground up, and you're used to thinking about, okay, I need some network. I'm going to speak to the network team. I need some storage. I'll go and speak to the storage team. I need some servers. I'll go and speak to the server team. Building all of that, everything for yourself from the kind of the ground up. Much more we're trying to look at how does certainly IT become a platform for the organization, and how does the organization become a platform for its customers, but and trying to think about things as platform services much more than kind of IT functions is driving a huge amount of collaboration, and we're seeing the breakdown of those sort of more traditional teams into a much more capability based sort of platform centric services. One of the, just to add on to that slightly as well, organizational structures tend to be a bit of a lag factor in this. So we're, for those familiar with Conway's law, I don't know if people come across Conway's law, but Conway said that for people building application systems end up building application systems that mirror the communication or organizational structures within their organization. So you end up, your functions start to look like your departments and things like that. So we're trying to sort of invert that slightly, and we're adopting a new model, and we're seeing that bleed back into the organization structure at the moment. And that's a really challenging thing, because that's the bit that unsettles the organization. The organization can sort of cope with a fairly high degree of change, provided sort of psychological factors like I don't change where I sit or who I report to don't change actually. People can cope with quite a lot of conceptual change as long as sort of on the ground everything looks familiar. But what we're seeing is needing to drive some of that sort of that conceptual change of how we think about the organization back into the organization as well, and restructuring ourselves around this approach. And that those are the harder things to do often, I think, because those are the sort of the emotional and psychological attachments that people have to the old model. They can lose the kind of intellectual attachments to how we do things quite quickly, but they're almost the social and the psychological attachments are much harder to overcome.
Yeah, no, absolutely. But I guess, in order to be able to adapt to being more agile and more efficient with the new solutions that you need to bring to market, I guess that from your perspective, it's an imperative that you're able to do this. So just digging in a little bit deeper on this, the way Equinix views organizations kind of fundamentally is with an IT core and then an edge. And obviously, edges will be different for different organizations. But I'm really interested in how you're thinking about connecting what is your core, the center of your IT operation today, with the edge that, both from a forecasting perspective and also, I guess, from a data analytics perspective.
Yeah, certainly, and it is having a big impact, and kind of slightly reimagining the way we perceive ourselves as an organization, what the core is and what our edges are. I'll just perhaps take a minute just to describe, I guess, the rough shape of the organization in terms of where we see our edges, and from a sort of a conceptual basis, and then talk perhaps a bit how that's changing. So for those that are familiar with the meteorological and weather forecasting process, then apologies for this, but I'll quickly, and probably to meteorologists, I apologize as well. As a technologist, I will attempt to represent the process of forecasting as best I can. But fundamentally, we're trying to predict the future state of the atmosphere, and in order to do that, we have to get the best possible understanding of the current state of the atmosphere. So observations become absolutely critical to that, and we're trying to capture the state of the entire Earth's atmosphere at a particular point in time. In order to do that, we have to take data from an absolutely sort of huge variety of places, from satellite data through to aircraft data, ship data, fixed station data, and the kind of sort of weather stations you see in kind of people's back gardens, or we send balloons up through the atmosphere to capture sense. And so we're we're pulling data from an absolutely sort of huge number of sources, and it's sort of terabytes and terabytes of data that's captured, and upwards of sort of hundreds and hundreds of millions of observations, equating to sort of billions of data points that are captured every day. So we've got kind of edges, if you like, sort of to a certain degree all over the world in terms of the sensor networks that we maintain and operate, sensor networks that other people operate, but we're able to either acquire the data from or host our sensors on their networks. And we also use crowdsourcing, a platform. We have one called the Weather Observations website, or WOW. Feel free to Google that in your spare time if you're keen, where you anybody can submit weather observations for their area. And it was kind of launched as a UK initiative, but actually we find we get people from all over the world. Really, everyone seems to be a closet meteorologist as well, and really enjoys contributing their observations, which make their way through ultimately into our weather model and in front of our forecasters to be able to get data points for parts of the world that are otherwise quite data sparse. So we have edges kind of around the world in terms of data capture and data input. That data is collected from all those kind of many diffuse edges and brought back effectively into the core for processing. So ultimately, all of those observations need to be used to construct a single environmental picture of what the Earth's atmosphere looks like. And then we use the weather models to advance that state through time to create predictions about what the atmosphere may look like in the future. So in the core, that's where the vast majority of our processing sort of comes in, and that's where our supercomputer lives, and that's kind of where we see as the core of the organization. That's typically lived in our data center. Once we've done that process of kind of running that model, that's a process that runs pretty much every hour of every day. We're constantly outputting data, roughly at the moment around about sort of 200 terabytes of data a day in terms of raw predictions. We then have quite a long processing chain that takes that output and turns that into meaningful meteorological data, be that national severe weather warnings that you warned about on your app or on the telly, or much more specific forecasts for aviation industry, defense industry, transport, energy. Basically every single industry in the world is affected by the weather in one form or another. So we've got a range of long post-processing and production chains that go to creating outputs for those industries and our customers. And then often those products need to make their way around the world back again. So we've got a lot of these industries that I've kind of mentioned there are global concerns, like the world aviation industry is huge. Defense industry could be operating at any part of the world at any moment in time. And we've got international partners working with other national met organizations. So our edge is almost at the input is the whole world. Everything gets pulled into a core for processing, and then the outputs, if you like, of that processing are then communicated out again to the whole world. So we have sort of outbound edges, if you like, from that perspective. The kind of sort of topology of that historically has been a lot of custom networks, if you like, on the observation side. The history of this is certainly a lot of completely custom built, custom configured, custom deployed observation networks and satellites running on proprietary or absolutely custom built equipment, bringing data back into our data centers in what were in Bracknell historically, but now Exeter, and then huge amounts of data being produced, and that data being sent out pretty much sort of wholesale out to customers to varying degrees of size. How we're seeing those kind of evolve now is that those edges are commoditizing. Those inbound edges are commoditizing. So what we're seeing is saw very recently, like kind of commercial space travel, but commercial satellites, a lot of those networks that we want to leverage are now commercial networks that are used for other things that we're able to kind of to use as data capture. So we take a lot of observations data from aircraft, for example, sensors based on aircraft, and we can leverage those. And a lot of the satellites, autonomous vehicles, obviously, are sort of the next wave of that as well, in terms of being a much more mobile network that you might be able to leverage to extract observations data from as well. So we're seeing sort of a lot of commoditization in the sensor network space. and we're able to leverage that. And we're seeing a lot of that data, first and foremost, being captured and processed close to the edge in the cloud. And we use AWS IoT platform to run our sensor networks, but equally we're seeing a lot of data being pulled in through those kind of often either commodity networks into public cloud. We're then seeing that data, obviously our supercomputer is currently next to, but our supercomputer are moving to Azure data centers. So we'll see that data moving from the AWS cloud where we're capturing a lot of information to Azure. It's becoming the new core where the supercomputer will be hosted. And then our on-premise data centers, where a number of our sort of legacy systems are hosted, will become our new edge, if you like. So what was our core becomes our edge, where we're running a number of kind of either legacy applications or geographical dependent applications, and then we'll be pushing data from that Azure cloud not only back to Exeter but also to our other edge locations, which may be in other clouds. We have, a lot of our digital applications are hosted in AWS. Our National Severe Weather Warning Service hosted in AWS. So we see there's kind of diffusion, if you like, of the core to a certain degree, although our dependence on centralized supercomputing maintains quite a significant presence at the core. But actually our on-premise just becomes another edge location, and we see other clouds becoming other edge locations as well if we move from cloud to cloud. So it's definitely the topology, even though the sort of the fundamentals of that, of collecting data from a diffuse network, centrally processing it and communicating the outcomes, hasn't changed. The topology of that network has changed considerably, and the commoditization of the technology that supports that network has changed considerably, and we're just kind of seeing that progress one step further.
I think this is all super interesting, and you can see why, talking about the capabilities and the platform-based organizational structure that you've been talking about is needed, because, this is significant in terms of change. One of the questions that kind of springs to mind as I was thinking about what you're saying is that, you talked about collecting the information, processing the data, and then pushing it out to the different entities that need to use that data, whether it's the airlines or whether it's the forecasters. Have you found as you're moving more to the cloud, are you finding that there is a requirement for an always on service, almost like an on demand, or is that something, so essentially your edge customers can pull the data, or will you still provide it on like an hourly basis? I mean, how do you see that changing?
So we certainly are seeing that changing. I think our certainly our previous dominant design was one of data push. So everything drove from the weather model itself. The weather model would output data, and then that data would generally be pushed either to either post-processing systems sort of within the organization or to our customers, where that led to some efficient, so optimizing those routes, which was absolutely the right thing to do for 50 or 60 years, then becomes a constraint when you need to change that paradigm. So as we start to move to data push, we're seeing data pull rather, we're seeing some of the kind of the tight coupling that exists to that previous data push model, where people are either dependent on you pushing, or they become often what we see is that they become dependent on, not on a service, but they come on dependent on actually some of the sort of integral moving parts of how your organization works. So we run multiple different models, and often we find the customers have actually attuned their processes to the knowledge that we run particular models at particular times that finish at particular times. So they've optimized their business to take account of that, and then when we change that creates a certain degree of kind of challenge and friction for our customers, because actually they've kind of coupled themselves to us to a degree which is very, very efficient, but then quite brittle when you want to change. So moving to the paradigm of data pull is really, really challenging for some customers, and really, really challenging for us to go on that journey with our customers. So for some people, it's much more straightforward. For those that kind of grown up in an API economy and you know, are kind of have always been API first, so very, very new organizations are used to kind of like, well, I'll just pull my data from an API when I need it. Why am I going to get all of the data that I might ever need and then pay to keep it and maintain it and look after it until I need it? I'll just go to an API and grab it when I need it, thanks. And you know, many organizations are, you know, either born that way or have, you know, successfully transformed to that kind of approach, but many haven't, and for many people, their overarching paradigm is still, no, step one is get the data, you know, go and get the data and then think about, you know, what we do with it, how we're going to use it, what we need it for, and that's a really, really challenging journey to go on with some customers, and some, you know, some of them really want to do that, and some of them are you know, are pretty happy with that model, because if they're using data where, you know, maybe the volumes aren't too prohibitive, that they can sustain that model. But certainly what we're seeing now is, with the injection of supercomputing capability, we're already producing, you know, 200 terabytes a day, and we're looking at, you know, probably a 10-20 fold increase in that over the coming years. You know, these data sets are too big to move. So what we can't continue to do is to, for all of our customers, run with the paradigm of sending them the data, because A, it takes too long, B, it costs too much, and C, they wouldn't want it or be able to use it when they got it. So there's a couple of paradigms emerging in parallel here. One is the sort of the API approach of allowing people to get just the data they need when they need it. So generally being able to extract much smaller pieces of data rather than having to take on the ownership and management and cost of having to ingest a huge amount of data. The other one is a much more platform centric approach, which is we're pursuing, which is actually just, you know, the best thing to do with a large amount of data is to leave it where it is and to bring your problem to the data. So if you're taking that data because you want to use that data to answer a question, which is 99% of the time what you want that data for, to help you make a decision of some form or other, actually it's much quicker and cheaper to bring your question to the data than it is to take your data to where you think your question is. So as part of this kind of platform thinking that we're evolving in the organization, it's looking at that paradigm of actually how do we help our customers bring their problem to our data, and sort of allow them to use our platform to answer their question, rather than having to burden them with taking terabytes worth of data and then having to also potentially deal with the challenges of, you know, we've got multidimensional data, which isn't always the easiest to handle and manipulate and manage. So there's quite a large overhead that comes with the management of that data. And if we're able to remove that from people, as well as facilitate them getting the answers to the questions they want answered, then that can be a real game changer for them. So some of it is about moving from that kind of primary data push paradigm to data pull, but some of it is actually around actually leaving the data where it is entirely, and just bringing your kind of question or business problem to the data, and using it in situ.
Yeah, again, that makes a great deal of sense. I can't imagine, you know, transferring the size of data files you're talking about across any internet connection. So one of the questions I've got, though, you know, as we think about how flexible IT needs to be, as you think about the growth of those data sets, and therefore the technology that's needed to house it and to take care of it and to make sure it's, you know, you can use it productively. Have you made any thoughts around, you know, looking at, instead of making big investments from a CapEx perspective, maybe moving towards an OpEx model, so you're actually making the investments as you go? And do you think this would help you to be more flexible and agile going forward?
Yeah, so back in kind of 2014, when we first were looking at kind of going on a cloud journey and seizing the opportunity of public cloud, the move from CapEx to OpEx was something that was really at the front of our minds. I think we were really conscious that a lot of the when we sort of went on that cloud journey, we worked closely with AWS and other public cloud providers, and we used partners. We used CloudReach at the time to partner with us to help us, support us on that. And a key message we were getting very early on was about the importance of kind of FinOps, our financial operations, if you like, as part of that move. That it wasn't about just, taking an IC system in one data center and putting it somewhere else. It was about, the whole paradigm of how you deliver is differently. And you do move from a predominantly CapEx environment to a much more OpEx driven environment. There was a huge opportunity in that, and we absolutely saw that, and that sort of steered our approach in the early days of cloud adoption, which was not to lift and shift. We kind of knew that if we took our sort of traditional IT and just picked it up and plopped it down in public cloud, actually that didn't offer us value for money as we swapped our sort of CapEx investment for what would be quite a high level of OpEx, and trying to maintain our existing estate just in a cloud environment did not offer sort of OpEx opportunities. So we were kind of conscious that in order to actually take the opportunity of OpEx as part of a cloud transformation, we had to sort of transform as we went. We couldn't sort of move first and then transform later. That would be a very expensive way of doing it. So our early sort of forays into cloud were either kind of cloud native applications that we built new, or things that were kind of, you could see how they would migrate to cloud paradigms fairly easy, fairly sort of straightforward to transform, and we saw some real efficiencies there. So our National Severe Weather Warning Service is a great example of that, where we were spending kind of thousands of pounds every month on kind of our virtual hosting environment to maintain servers for if and when national severe weather warnings needed to be issued. But we were able to transform that to a serverless kind of Lambda-based environment, which now, if there aren't any national severe weather warnings, costs us nothing every month. So, and even when we do issue warnings, it's a matter of sort of $5, $10, $15, if you like, to maintain the infrastructure that supports our national severe weather warnings. So there was a huge lure of OpEx, but as we sort of speed up that kind of transformation and move more and more things move to the cloud, we're kind of having to be even more conscious about some of the constraints that kind of OpEx poses. And I'm going to mention the Jevons paradox, and I'll probably completely misquote it, but so apologies for those who are well acquainted with it. But broadly speaking, it says that as efficiency increases value, then that increases the use. So actually, the cheaper and easier you make something, it gets cheaper, but actually the more you end up using of it because it's cheap and easy to use. And I think energy efficient or cheap LED lighting is a good example of this, where we were spending a lot of money on lighting costs, just to burn the old incandescent bulbs was very expensive. So much more efficient lighting was developed that reduced the amount of energy that was spent on lighting, but because it then became very cheap and accessible, people used more and more lighting, and as a result of energy efficient lighting, actually the total energy bill for lighting increased, because as you make things more efficient, people just use more of it. So we were kind of aware of that challenge around, some of that you want because you're using more of it, because you're using that to scale effectively, you're using that to support customer demand, and that's great. And if that scale and that usage is tied to, you've got a cost model that supports that increase in scale and that increase in use, then great. But if you don't, and you're just looking at removing the sort of physical constraints that came with perhaps traditional infrastructure or CapEx driven infrastructure investment, and just allowing yourself to do more, that's where there's a potential challenge there in terms of how you manage that OpEx. So that's where having kind of good guardrails, good financial governance and spend controls in place to kind of understand how you're going to allow that OpEx to be driven is really, really important. So OpEx was a huge opportunity for us, but one we're sort of quite careful about. And kind of as we move into the next generation of this, when we look at some of our data storage, perhaps is a good example of that, where we've got hundred petabyte archive of meteorological data, which we predominantly stored on tapes, on tape drives in our data centers. And when you've bought an enormous tape drive, because you've done your capacity management, you know how much data you've got, you know how much it's going to grow, and you've made that investment in it, there's no incentive not to fill it up at that point. There's not the pressure on having the kind of the good data governance processes and regimes that perhaps encourage you to use that storage efficiently because you've already paid for it. So, there's no incentive not to just fill it up. But as we move from kind of that environment into a much more sort of cloud-based environment, and we look at the size and scale of that storage, in some ways, we've got more constraints there, certainly more cost constraints there, but actually we can use that to drive much better practice and go, are we storing the things we actually need to store? How much of this hundreds of petabytes of data are we storing because it's valuable and we need it and we want to use it? How much are we just storing because, it costs us nothing to just store it, so we just keep it without having sort of any mind to the value it represents? So we're still trying to see that kind of OPEX driver as an opportunity, both to reduce cost on the one hand, but also just to enforce better discipline, if you like, in terms of some of our management processes and the way we activate that OPEX. So there are huge OPEX opportunities there still. Obviously also huge risks of, if you don't get that governance right, if you don't get those constraints right, then you can end up in the sort of the bad place of that paradox of increasing your use, but not necessarily having the control over that you'd like. And we still have to be really conscious that we're a part of government, we're owned by BEIS, and government is still a very, very largely capex driven environment. Ministers like to announce things, we like to announce big investments in things with a big headline number, and people like to know exactly where that money's going, how it's going to be spent at the point at which they make an announcement about it. And that's politics rather than economics or technology, but that's just a fact of life in government. So there will always be a significant capex angle to things, which we have to embrace at a certain level and understand, and B, that is absolutely the right approach for some things. High certainty, high commodity things with low variability. Capex offers you actually a better return or a better sort of overall efficiency than moving to OPEX approaches. But we're trying to mature in our kind of ability to understand where we have to use one over the other, because that's the imperative, but be very mindful of what the strengths and weaknesses of orienting around either capex or opex are, what the pitfalls are, and how do we protect ourselves against the challenges of both approaches. So we're definitely moving from an environment that was almost solely capex with little bits of opex to a much more mixed economy, and we're sort of trying to work out how to thrive in kind of both of those.
So essentially keeping everything in balance. And I think that was really interesting. I really like the analogy with the light bulbs. I remember growing up and my parents telling me constantly to turn the light off. And now we never even think about it. So it is interesting. So my very last question, James, and we only have a couple of minutes left, is really looking towards the future. How do you see the future of the business evolving and changing? And what are you going to need from partners and service providers to make it possible?
Cool. So as we move forward as an organisation and develop our understanding of kind of the platform approach that we're taking within the organisation, the key for us is understanding where we fit in a much broader kind of ecosystem, if you like. So platforms are really challenging word actually within the organisation industry as a whole. It gets used an awful lot, and we're doing quite a bit of work at the moment internally to try and raise the kind of general level of awareness of what platforms are and how they work, all the way through from bare metal as a platform, all the way through to kind of software as a service and your kind of sales forces as platforms for your business, and everything in between through kind of virtual services, infrastructure as service, platform as the sort of traditional platform as service options, and into serverless and approaching the software as a service. All of these are platforms, and trying to understand what they are, how they're useful, and what role we play in that. And that's where we see ourselves operating as an organization of no longer really being in the business of some of that core infrastructure that we were in out of necessity back in the 1960s when no one else had supercomputers and no one else had observations networks, so we built them, or amongst the very early adopters of some of those technologies, through to actually that's not where we need to be anymore. That's not where we need to innovate. We can rely on the likes of Amazon, Microsoft, Google, Alibaba to innovate for us in that domain. That's not where our expertise is, or isn't any longer. because it's not a differentiator there. We can't differentiate as a meteorological organization by innovating in that space. So that's where we look to partner with other platform providers at that level to leverage the innovation they provide. Similarly, we need to sort of look above us and see, well, what do our customers want? As we kind of mentioned, the paradigm potentially of just being a sort of data disseminator to a certain degree is a paradigm that starts to break down when you look at the impact of big data in terms of the volume of it, the velocity of it, the variety of it that's available. Actually, it's overwhelming. It's like people trying to take a drink from a fire hose is sort of classical analogy there, where actually, how do you remove the burden of having to handle data from a lot of people who aren't data organizations? They don't want to be data organizations. They want to do whatever they do. Civil Aviation Authority wants planes to take off and land successfully. They don't want necessarily to have to manage huge amounts of environmental data. So we're looking at ourselves and going, what innovation do we need to provide to be a platform for others to be able to do a lot of the heavy lifting that our infrastructure platform providers are doing for us? How do we do some of that environmental data platform heavy lifting for others, so that they can leverage their own services on top of that? So really, it's about seeing the part we play in the ecosystem, working out the innovation we can leverage from others and those around us to do remove the burden of the things that aren't our core business. Focus on innovation in our sort of our core strengths as an organization around scientific innovation, the uses of data and analysis of data, and to a certain degree sort of distribution, visualization of that data, and then seeing how we can use those capabilities to help support others by providing platform services for them. That's sort of the key for me in terms of how we move forward.
I think that's really interesting, and it kind of brings us all the way back around to collaboration, which is one of our earlier points. Collaboration between yourselves, your partners, and your customers is going to be essential, all on a single platform, so that you can be provide an efficient service. So we're out of time now, James. Thank you so much. We really do appreciate the time you've taken. It's been really interesting. I'm going to hand now back to Shama to actually tell us what we need to do next.
No problem. Thanks very much.
Thanks, Erin, and thank you so much, James, for that. That was really interesting to hear your thoughts on all of those questions. So thank you.